Okay, guys, so welcome to the new class. So this is a new chapter. We'll start work, power, and energy. Am I correct? Siddhi, is this chapter is there in your book?
Yes.
Yeah. So what is work? What is work? Pritam, what is
The
work?
work is the uh,
What is work? If I say formula wise, I will say F dot S. F dot S. Okay. Work is basically a scalar product. It's a scalar product. Why? You remember I told you that I don't, yeah. So remember I taught you that there is a dot product of two vectors. If there is a dot product of two vectors, you will get what? Scalar. Yes or no? For a dot product of two vectors, you will get scalar. But a cross product of two vectors, what you will get? You will get a
vector.
vector. So since F is a vector, S is a vector, the dot product of two vectors will always give a scalar. That's why work is a scalar quantity. Clear? Clear? Okay. And what is its unit? Its unit is what? Joules. Clear? Clear? Work is joules. So what is positive work? What is negative work? If the system does work, system gains energy, we say it is positive work. Gains energy, it's positive work. If system loses energy, it's called negative work. Clear? Clear?
Yes, sir.
Okay. We are using fundamentals. Okay, these are the fundamentals. Then what is variable? What is variable force? Then basically, when I say work is nothing but F dot S. This is a what? Constant force applied for a particular displacement gives a work. Here it is a constant force. But when I talk about variable force, let's say my force is varying at each moment, then what will happen? Then the work will be variable. That means for this particular length till this much, I am applying maximum force. Here it is varying. Here it is F1. Here it is F2. Here it is F3. Here it is F4. Here it is F5. Then and here it is S1, S2, S3, S4, S5. So at particular instant for this much, your W will be what? W1 plus W2 plus W3 plus W4 plus W5. Why? Because here force is varying. So what will be W1? W1 will be F1 into S1. W2 will be 1 minute. लक्ष्य किधर है तू? क्लास तेरे को पता नहीं है 5:30 बजे क्लास रहता है? मतलब मेरे को रिमाइंड करूंगा क्या लक्ष्य? आधा घंटा चालू हो गया, जल्दी ज्वाइन कर रहा है? जल्दी ज्वाइन कर. W1, W2, W3, W4. So for W1 it will be F1 in dot S1. W2 will be F2 dot S2. So like that you will have Fn dot Sn. So here it is basically what? Here we are fixed. It is fixed so that we can add it. But let's say it is varying at each moment. Then what will happen? Then we'll integrate with a integration. It will be x1 to x2. Here it will be f dot dx. Why? Because here it is fixed. It's basically integration. We are talking about force varying at each particular moment. This small, it's a basically small displacement. And what is x1, x2? It's a limit. Till what to what? x1 till x2. Particular moment. So either the force might be varying or the displacement might be varying. Either or, if both are varying, then also we get a variable work. And if one is varying, then also we get a variable work. Clear? Are we clear? Clear?
Yes, sir.
Okay.
Yes, sir.
It is not necessary that if displacement is 0, total work done also is 0. Means what? Means what? Displacement, you remember I told you, right? There is a point A and there is a point B. If let's say you want to go from A to B and then you come to B to A, then what happens? Your displacement becomes what? 0. Am I correct?
Yes, sir.
But remember, even if the displacement is 0, that doesn't mean that what? The work is 0. Why? We will come back to it. We'll come back to it. So remember, work done is not 0. Sorry. What I'm saying, it is not necessary that if displacement is 0, work done means if the displacement is 0, it is not necessary that work done will become 0. Work done will still have a value, and I will come to this. Please remind me. I will come to that. Okay? I will
Sir,
come.
no, sir. Sir, actually, like, if displacement is 0, then the work done is 0, sir.
No. Who said?
Yes, sir. Work done is equal to force into displacement only, no, sir.
Correct.
Yes, sir. So
Then?
displacement is 0, then work done is 0, sir.
There is a concept called conservative force, non-conservative force. I will come to that. That's why I told you it is not so. It is not so. Guys, 1 minute. So Pritam, there is a concept called conservative force, non-conservative force. Understood? So we'll come to that. Then only we'll understand. Okay? You will understand.
Sir, actually, the net work done is 0, sir. Yes, sir. I know that, sir, about conservative and non-conservative.
Okay. That's what I'm trying to say.
But the net work done is 0, sir.
Net work done is 0. I did not say net work done, no. I did not say net work done is not 0. Net work done is obviously 0. You do work here, you do work here. Correct?
Yes, sir.
The net work done is 0. But I am not talking about net work done. I am talking about only work. Clear? I have not come to that. So hold on. Don't get confused. You studied, others have not studied. I'll come to that. Clear, all of you? So we'll teach you what is conservative force. First, we'll understand what is conservative force. So what do you know about conservative force, Pritam? Pritam, what is conservative force?
Sir, the work done by such force, it depends on it does not depend on the path taken by the object, sir.
Correct. So that means these forces are independent or do not depend on the path. Means if I am going from A to B, whether you go like this or whether you go like this or whether you go like this, it does not matter. It matters what is the initial point and what is the final point. If any force which is not dependent on the path but only depends on the initial and final point, then these forces are called conservative force. And what are the examples of those forces? One is gravitational force. Clear? Next is electrostatic force, and then it is spring force. Clear? These forces are called conservative force. They are not dependent on the path but only depend on initial and final position. Clear? Clear?
Yes, sir. Yes, sir.
And remember, the work done by such forces in a closed path is always zero, which is Pritham is trying to say. The work done by these forces in a closed path means closed path is always zero. Clear? The work done by conservative force in a closed path is always zero. Then what is non-conservative force? Obviously, it will depend on path. Clear? Then what are the example of non-conservative force, Pritham?
Sir, friction, sir.
Friction, and what else? What else? Friction, any type of friction? Yeah, all type of friction. It can be air friction,
Yes, sir.
it can be water friction, and also surface tension.
Yes, sir.
Yeah, and also buoyancy, buoyant force.
I'm not sure about that, sir. Like,
Yeah, buoyant force also is one of the non-conservative force. Okay, so if you want to summarize what is conservative force, non-conservative force, conservative force, non-conservative force. Conservative force are path independent. These are path dependent. Okay. Okay. In conservative path, if I have two final point, this is W1, this W2. Here W1 is equal to W2. But here W1 and W2 is not same. Remember that. In a closed path, it is always zero. Work is always zero. But here, work is not equal to zero. Examples: gravitational force, electrostatic force, spring force. Here it is buoyant force, friction, and surface tension. We will come to surface tension later on. Clear?
so
Okay.
1 second, sir. I'll copy this.
Yeah. Siddhi clear? Swarup clear?
Sir.
Okay.
Sir, clear, sir.
Laksh, this is the final time. I am not going to remind, guys. My job is not to remind you that you have class. Class is there at particular time. Everybody should know and join. I am not going to put any message further henceforth. Class will be in Zoom always, same ID. If there is any changes, I will reply. If class is being not held, I will reply. If I am not reply, that means class is going on the normal time. I am not going to stop. I will wait only till 5 minutes max. If somebody has a problem, they should inform me, sir, I have a problem. I am not able to join anything. Clear? Everybody
Yes, sir.
clear? My job is not to remind you. My job is to, have I seen any time that I am late? No. I treat it very seriously. If I am late, I will inform everybody that I am late because of some network issue. That cannot happen. Maybe once or twice it might would have happened, but I'm not sure anytime it happens. I don't like, first of all. You are studying, guys. It's a very hard year. Please understand. Please try to use the opportunity. Whoever is teaching, wherever you are getting proper coaching, please take up. Now see, Laksh, your class didn't start. Do you know that how kitna piche ho tum? अभी क्या सीन है क्लास का? Is it going to start or not? Laksh, what about your class? Is it going to start?
No, sir, it hasn't started yet.
CBSE already started. Pritham is almost half the way. That's why I always tell CBSE, because they are very professional. Dates are announced, exam dates are announced already, so that you don't have a fear. I don't know why they are spoiling future. Okay, have you written down this point? Shall I go ahead?
Sir, what
Yes,
are the
sir.
examples for non-conservative, sir? Friction?
Friction, surface tension, buoyancy.
Okay, sir. Yes, sir. You can erase it, sir.
Okay. So now you have a force. You have a force which is a three-dimensional force. I can write this force as Fx I cap, Fy j cap, and Fz k cap. If any force is conservative, if any force is conservative, then what happened? Your dfx, dou fx by dou y is equal to dou fy by dou, 1 minute, huh? Yeah, dou x. Dou fx by dou f dou z is equal to dou fz by dou x, and then dou fy by dou z equal to dou fz by dou y. Now what is dou? Anybody knows what is this dou? Does anybody know what is dou? What is this called? It's called partial differentiation. What it is called? Partial differentiation. Yes or no? Are you aware? Was it taught? Yes?
No, no, sir. No,
No, don't worry. We will teach you. So, what is differentiation? Differentiation is we partial differentiation means you are only partially differentiating. So, how to do it? We will see later on. Clear? Just note down this.
sir. 1 second, sir. I'll copy this.
Yeah, note down. We will see how it happens. Just note down. Siddhi, you didn't learn this 11th?
No, sir, I don't remember.
Don't remember. How will you prove if force is conservative or not? By heart. Out বন্ধ করে দিন। Shall we go ahead?
1 second, sir.
Yeah.
Yes, sir.
Yeah. Okay. So when I say force is conservative, I have a force which is xi cap plus yj cap plus 0k cap. Then when I say dou fx by dou y means what? I am differentiating this component with respect to y. Now tell me, y is equal to x square. If I say dy by dx, it means what? X to the power n, nx to the power n minus 1, which is equal to 2x. Yes or no? This you would have learned. Correct or not? That means This one you are respecting with respect to x because it's a variable. Y is a what variable? Dependent variable. X is an independent variable. You are differentiating an independent variable with respect to x. But now you tell me x, if I say dou x by dou y, can I differentiate x with respect to y? X and y are two different variables which are not in relation. That means dou x by dou y will become what? 0. That means x is not changing with respect to y. X is constant with respect to y. So your dou x with respect to y will be 0. Similarly, your dou y, the y component. Prema, I'm in a class. Can I call you back? So dou y with respect to dou x. Now, this one with respect to x is not this thing, it is constant. So dou y by dou x is also 0. Clear? If this is 0, this is 0, that means both are equal. Clear? Now, clear or not?
Sir, can you explain this again, sir? I'm not able to understand.
Arey Baba, it's a x component. What is this? This is the x component. Now you want to differentiate the x component with respect to y. Can you differentiate x component with respect to y? No. You can't differentiate.
Oh, yes. Yes, sir. Yes, sir.
X and y are irrelevant. X is maybe a constant for y. So dx by dy is 0. Similarly, dy by dx will be 0. Clear? Clear? See, what is fx? Fx is the x component of the force. You want to trying to differentiate x component of the force. You are trying to differentiate with y. So fx has no relation with y. That's why it is 0. If all these are 0, then it is what? It is conservative. Force is conservative. Clear? Understood?
Sir, all this should be equal or it should be 0, sir?
It will be equal only when it is 0, no? It cannot be equal. Only when it is 0 only it can be equal.
Sir, it can be some constant, no, sir? Like
No,
three,
it
something like that.
cannot be. It cannot be. It cannot be.
Okay.
It cannot be, no? How it will be? You tell me how it will be. How you will get a constant? Here it will be x square. It will be y square. It cannot be. Not possible.
Oh, okay, sir. Yes, sir.
Okay. Clear, all of you? So remember, if F has to be a conservative force, then it will be this relation should exist. Clear? Yeah?
One second, sir.
Yeah.
I will copy this.
Yeah. Laksh, Swarup, Siddhi.
Sir, I have a doubt, sir.
Yeah.
Yes, sir. Understood, sir.
Sir,
Tell me.
sir, what is the difference between D and dou, sir?
Okay. Dou is partial differentiation. See, you have this is basically a vector, correct? You are differentiating everybody with respect to x. Then it is a normal differentiation, D. Okay.
Oh, okay, sir.
But if you are differentiating variable with this x, y, partially you are differentiating, then it is dou. Like this.
Oh, okay, sir.
You will learn it in your grad days. Graduation you will study. Partial differentiation. Not now. Not required. Just remember this much. Why force is conservative? Force is conservative only when this holds. See, how will you remember? Fx dx, dy, fy dy, fy y, fx x, fz z, fy y, fz z. Like this you will remember. Okay?
Yes, sir.
Okay. Now let us go to the next topic, work energy theorem. Work energy theorem. What is this? What is this? What is work energy theorem? Work done, write down the definition of that. It means work done by all the forces. When I say all the forces, it means what? It means both internal force and external force. Work done by all the forces is equal to change in kinetic energy of the body. Change in kinetic energy of the body. Or I can write like this as K final minus Ke initial. That's all. Clear, guys?
Once again, sir.
Yeah. लक्ष्य समझ में आ रहा है?
हाँ सर.
Okay. Okay, on this we'll do a small problem. A 5 kg ball, a 5 kg ball falls through a height of 20 meter. Okay, falls through a height of 20 meter. Find the work done by the resistance. No, not this. 1 minute. Huh? A ball of 100 grams moving at a speed of 100 kilometer per hour. Okay, a vehicle of 100 kg moving at a speed of 100 kilometer per hour, okay, exceeds to a speed of 150 kilometer per hour. Clear? What is the work done? So how will you do? So now when the body was actually moving first, your V1 was how much? 100 kilometer per hour. It suddenly went to, this is the initial velocity, and the final velocity became 150 kilometer per hour. Am I correct? Yes or no? And the mass of the body vehicle is how much? 100 kg. I am saying what is the work done. So what did we learn? That work done is nothing but change in the kinetic energy of the body. Now initial kinetic energy become, what is the formula for kinetic energy? Half mv square. So if I say kinetic initial, it is half mv vi square. That means half into 100 kg into 100 square. And what is K final? K final will be half into 100 kg into 150 into 150. Correct or not? Yes?
Yes, sir.
So if you divide, this will become 50, this will be 50. So basically what? This minus this, that means 150 square minus 100 square and multiplied with respect to 50. So this is basically what formula? A square minus B square formula. It will be 150 plus 100, 150 minus 100 into 50. So 150 plus 100 is 250. 150 minus 100 is 50, and you have already a 50. So 250 into 50 into 50. So it will be what? 25, 25, 25, 25, 625. How many zero? 1, 2, 3. That means 625 kilojoules. Clear?
Yes, sir.
Clear all of you?
Yes, sir.
Very easy. For any easy problem? कोई दिक्कत है क्या?
नहीं sir.
No दिक्कत. No problem. Okay. Then now we will go to, now let us not teach anymore. I'll too much of concepts. We'll study in next class. So we have started the work energy theorem. We'll go to the advanced concept in the next class. Okay. I don't want to go ahead with the new chapter so much. Let us give a halt. So next class, guys, I request you to be on time. I'm not going to call upon. If somebody is not coming within 5 minutes, I'm going to start off. Okay? Clear?
Yes, sir.
And recording will not be given to that person. You
Yes,
will not
sir.
get
And
recording
that
also.
will not happen again.
No, I'm talking about everybody, Laksh. I'm not telling only you. I'm talking about everybody. Every time it is happening that I am calling everybody. If somebody is joining late, please inform me that you are joining late. Clear? Clear, no? All of you?
Yes, sir. Yes,
Sure.
sir.
ठीक
Yes,
है.
sir.
Laksh, your class is on Monday. Yeah? Monday. I am doing it on Monday and Tuesday, not on Wednesday.
Ye-
Okay.
Yes, sir. Yes, sir.
Your
Sure.
morning class. Siddhi,
Yeah, 8:30. Okay.
yeah, 8:30. Siddhi, you had some doubts of kinetic energy theorem. We'll do it tomorrow. Please come back tomorrow to Lata ma'am's house. Okay.
Yes, sir.
Okay. Pritam, chalo, take care, all of you. Bye.
Bye,
Sir,
sir.
Yeah. Tell me.
it has the proof now, sir, for this work energy theorem.
Proof, is it there in your syllabus?
Yes, sir.
I will do it in the tomorrow's class. Okay.
Yes, sir. So tomorrow we don't have any class, sir.
When I said tomorrow, it means next class I will do it. Okay.
Yes, sir. Yes, sir.
Yeah, just let me know whatever is missed, because I might miss. So please, all of you, I request you to check your syllabus. What is there, what is not there, so that we are on the same page. That should be your duty. Okay. Because you are different boards, all of you. Clear?
Yes, sir.
Yeah. Bye.
Thank you,
Thank you,
sir.
sir.
Bye, sir.